our next session is ZFS 101. Why it's cool and why you should be using it. Our speaker is Drew Lavigne, so without further ado, I give you Drew.
Okay. We finally made it. So today we're going to talk about ZFS and some of the reasons why it's cool. Is anybody using ZFS right now? Okay. So I know myself, every time I talk about ZFS, I learn some new cool feature that I hadn't yet heard of, because ZFS, there's just so much to it. So hopefully, even if you are already familiar with ZFS, you'll still get something out of this talk. So what we're going to discuss, we're going to take a look at some of the features that make ZFS a compelling file system, not just for servers, but also for desktop systems, and also why it's really appropriate for storage. And as I'm going through the features, I'm going to show how these features have been integrated into graphical tools. Most people who have played with ZFS have dropped down to the command line, and you're following a tutorial to figure out how do I set up my pools, set my properties and data sets. That's a really good way to learn the inner workings of ZFS, but sometimes it's just nice to have tools built into your OS where you can go clickety click click, it will do what you want it to do. So we're going to be looking at the tools in FreeNAS, which is an open source storage appliance based on FreeBSD, looking at the latest release, 9.2.1. And we're also going to take a look at PC-BSD, which provides a graphical desktop as well as a command line server. And we'll concentrate on the graphical tools in the latest release, which is 10.0. When I'm talking about ZFS in these particular operating systems, both of them are at the latest versions of ZFS, and we're going to talk a little bit about what that is. So if you see the term feature flags, they are at the most recent set of feature flags. So let's start by taking a look at the history of ZFS. So ZFS was originally designed at Sun. As we all know, Sun is no more, and it's gone into the grip of Oracle. And when that happened, it was really up in the air what is going to happen with ZFS. Nobody trusted Oracle to actually continue any open source development or to send any patches into open source projects. So it was sort of up in the air for a while. Is every project that uses ZFS going to have to rewrite the wheel to get its own features in? Everybody was all upset that Sun sold before the encryption features in ZFS actually made it into open source. Fortunately, that has settled down, and the original two Sun engineers who designed and developed ZFS actually started the Open ZFS project. It's open-zfs.org, because openzfs.org was already taken. You can leave that. So they are continuing development. If you are interested in file systems and ZFS in particular, I recommend that you go to their website. They actually have an online monthly meeting where you can ask ZFS questions from the people who actually designed ZFS. Yes?
Do you know who owns the patents on ZFS?
So the stuff that is open source was all under an open source license. So when development stopped at version 28, what they did when they started OpenZFS is they said we need to distinguish ourselves from the version numbers that Sun is continuing to increment. So we're going to pick a huge number, 5,000. So if you see version 5,000 on a system running ZFS, it's running the open version. And that is under the CUDL or the CDDL license. The nice thing about the OpenZFS project is Linux, FreeBSD, what's left of Open Solaris, all those projects are continuing to work on that roadmap and to add and integrate the features. So that's what happened with the open source part of ZFS. If we take a look at what is ZFS itself, well, it's a file system. It allows for very big files as well as file systems because it's 128-bit. The part that makes ZFS compelling is the copy on write part. So copy on write means when you edit a file, the original disk blocks never get touched. So that new portion of the file is written elsewhere on your disk blocks. This allows you to do really cool things like keep versions of files and to roll back to earlier versions of files because those disk blocks are overwritten. The other thing that takes a while to wrap your head around if you're used to traditional Unix file systems, when you're partitioning your disk, you need to think ahead of time. How big is root going to be? How much do I need for USR? How big is var going to be? Because these are set at the time that you format your file system. ZFS thinks differently. So ZFS wants you to feed it a bunch of disks, which are known as a pool. And from that, you create your file systems as you need them. And I'll walk through that a bit as we go through this presentation. So it doesn't mean you have to have your fixed sizes thought out ahead of time when you're going to format your disks. So let's take a look at that concept of a pool. So basically think of this as the root of your file system. As you go and create other file systems, they're going to come off of the pool. You still need, if you are creating, especially if you're creating something like large storage or you're starting to deal with multiple disks, you still have to do some design thought ahead of time. How do I want to scale the size of my file system? So if you are working with multiple disks, what you do is you feed a certain amount of disks at a time into the pool, and that is known as a virtual device or a VDEV. And we'll go through on another screen how ZFS writes its parity and its data to disks. It's optimized for a certain number of disks at a time. The other thing that you don't want to do on a ZFS system is, let's say you have 40 disks that you're going to use to create storage. Don't put 40 disks into a VDEV. A VDEV, you want to actually optimize things as they're being read and written. And the other thing is if you ever have to replace the disk, you have to actually recreate that. That process is known as resilvering. If you lose one disk out of 40 and something happens before those 40 disks resilver, you may find yourself with an inaccessible pool. So you think about these things ahead of time. The nice thing is once you've decided this is how many disks I'll add at a time, as you need to scale, you just add an identical number of disks and you end up striking your VDEVs. We're going to look at how we actually do that. One of the design elements in ZFS was to replace hardware RAID that actually wanted to do it at the file system level. And for a couple of reasons. One is that there is some inherent problems built into hardware RAID. So sometimes it will silently write corrupt data for a period of time before it bothers to tell you there's a problem with a controller or a disk. And that's something that can happen with hardware RAID. So what ZFS attempts to do is to work directly with your disks. This gives you an added benefit in that you don't have to purchase a RAID controller. You can still use ZFS if you have a RAID controller, but typically you're putting that controller into JBOD mode. When you use the RAID for ZFS, it'll always be called a RAID Z with a number after it. That number represents how many disks you can lose in a VDEV without losing data. And this is another reason why you don't put 40 disks into a VDEV. You do blocks of, say, 5 or 6. So if we're looking at a RAID Z1, that means you can lose one disk without losing your data, and that's per VDEV. The other thing that RAID Z does differently than hardware RAID is your parity blocks are always distributed across all of your disks. So you don't end up with a single point of failure. And this one, ZFS works best in a RAID Z1 if you feed it 3, 5, or 9 disks at a time. That's just a basic rule of thumb. It comes out of some mathematics, how ZFS works. With a RAID Z2, this is going to be similar to a RAID 6 because you can lose 2 disks per VDEV without losing your data. And this one is optimized for 4, 6, or 10 disks. Right now, the highest level of RAID protection is RAID Z3, where you can actually lose 3 disks per VDEV. And this one is optimized for 5, 7, or 11 disks. Now, if we take a look at the tools that we have available, both FreeNAS and PC-BSD have built into them the logic to pick the right number of disks for the type of RAID Z that you want to create. So it's very handy. It'll actually let you know if you're picking the wrong number of disks for what you're trying to create. So if I'm looking at a FreeNAS system, FreeNAS, the operating system itself, lives on a separate disk, typically an SSD or a thumb drive. So you set up your storage disk after the installation. So this is the FreeNAS web interface. We have something that's surprisingly called storage. You go into ZFS Volume Manager, you give your volume a name, and then it will tell you how many disks you have available, and it gives you a little slider where you can select the number of disks that you want to put in a VDEV. In this example, I happen to have 5 disks. 1 isn't used yet. I've done 4 here. If I had, say, 40 disks, I could create 5 at a time, and then just go in and add the blocks that I need. So I can create multiple VDEVs at a time. As I'm dragging the slider, it'll automatically pick the optimized RAID Z for that number of disks. So 4 disks is optimized for RAID Z2. If I kept RAID Z2 and did the 5th disk, this would go red and say this is a non-optimal configuration, and it has a hyperlink to that point in the documentation that tells you this is the correct number of disks for a RAID Z. So that's in FreeNAS. PC-BSD, if I'm setting up either a desktop or a server, and I happen to have multiple disks, I can just say that yes, I do want to create either a mirror or a RAID Z. In this example, I just did this in VirtualBox. I created a bunch of virtual disks. And as I check off the disks that I want to use, it'll automatically tell me that this is optimized for this type of RAID Z. And it won't let me pick a RAID Z that it isn't optimized for. It also, if I say only pick 2 disks, it wouldn't let me make a RAID Z1 because I need at least 3 disks to make a RAID Z1. So that logic is built in for you. A couple of other terms that we get with ZFS. We have something known as the ZIL, or the ZFS Intent Log. Basically, this is your write log. This is where your writes are stored before they're committed to disk. If you are using an application that uses a lot of sync writes, you want to have a streaming ZIL, because that will really improve your write performance. It's not going to do anything at all for async writes, though, and that's always going to be at the application level. If you're on a system that has a lot of writes and you're thinking maybe I should have a second ZIL device because I really want my writes to be very fast, you can add another device that'll be known as a S-Log. Typically, you put it on a fast device, something like an SSD, because you really want to take advantage of that. What we tell people, if you're using asynchronous, don't bother. You save yourself the price of an SSD. And if you're not sure if your writes would benefit from this or not, in FreeNAS we have a utility called ZILstat, and it will let you know if your system would benefit from adding a secondary log. And in our documentation, it tells you how to run ZILstat and to interpret the results. Yes?
In PC-BSD, can you use kind of like, I guess, cheaper like MLC type drives and then turn up like what's the word? the extra space way up high and then just let that thing get eaten up by it?
Yeah, you could.
You could do that?
Yeah.
And then you could put like a pair up maybe if you just had like 2 spaces in and then swap them out as needed. Because when you lose your ZIL,
Depends upon the version of ZFS.
Oh, okay.
So when we were way back in the days of ZFS version 15, you had problems if you lost a mirrored ZIL. That was fixed after ZFS version 15. So that was a couple of years ago. So you don't have to worry about that part anymore. But it really depends upon the type of writes that you're doing.
Okay.
Cool. The other thing that a lot of people think they need, and sometimes they do and sometimes they don't, is a layer 2 arc or an L2 arc. So ZFS maintains and RAM its own arc, and this is where it tracks reads. So we all know it's always faster to get things out of memory than to have to go to disk in order to read something. So what you really want is you want the stuff that's being read most often to be coming out of RAM. If you find that you're still going to disk to get your reads, you can probably benefit from an L2 arc. What some people try to do is they say, well, this board will only take so much RAM, so let's throw in an SSD and we'll do an L2 arc instead. And that is a terrible thing to do because you always want to have a good amount of RAM. So an L2 arc isn't supposed to replace not having enough RAM in the system because it actually makes your RAM work harder to maintain the L2 arc. If you do have enough RAM in the system and you have an SSD, L2 arc will speed up your reads. And again, typically this is something that's more on a storage device. So if FreeNAS gives us a couple of ways to look at our ARC and L2 arc. So we've added those statistics to top. And we also have ARC summary and ARC stat that will actually show you your running ARC as well as a summary of your ARC. So ideally you're trying to make sure that things are coming out of RAM instead of disk. If I want to add either a secondary log device or an L2 ARC in FreeNAS, I can go back into my ZFS volume manager. I could have done this when I made the pool in the first place. So if I had an extra device or an extra SSD, I could have added it as either a ZIL or an L2 ARC. If over time I decided I could really benefit from this, all I have to do is go in and select the volume and then select the device to make the slog or the L2 ARC. If I'm on a PC-BSD system, this is something that we do post-install. So PC-BSD 10 introduced a new utility called Disk Manager, where you manage all of your ZFS stuff post-install. So I can go in and add devices to my pool, I can add a cache device, or I can add a log device. Now we start getting into how do I actually make file systems. So I've thrown my disks into a pool, how do I actually logically divide up my data? So there's a couple of ways we can do that. Typically we create things known as data sets, but a data set is really a file system. But data sets are interesting. They're also similar to a folder because you can set permissions on a data set. The other thing that you can do is set ZFS properties. And this is where you can really take advantage of what you're going to store in certain parts of your file system. So for example, if you want to store files that could benefit from compression, I could create a data set for those files and turn on the compression property. If I want to give each user or create my home directories, each on their own data set, I could set quotas on that user's data set so one user doesn't go and take up the whole pool. And really, as you need and think of ways that you can optimize your storage, you can create data sets to do that. If we take a closer look at those properties, there's literally dozens of different properties that you can set, and I've listed some of them. When you're looking at a FreeBSD-based system, there is a man page. If you just do man ZFS, the man pages are online. It'll list all of the properties. To add add a data set on FreeNAS. Now that I've already created a volume, I can click on that volume and create a ZFS data set. Typically, it's as simple as giving it a name and clicking Add Data Set. I can go in and set some of the properties in there, and I have an advanced screen. I can set additional properties. PC-BSD, I can either do this during installation or post-installation. So the installer itself will create a bunch of data sets for you. These data sets are used for individual home directories, and they're also tied into our backup tools and some of the other tools I'm going to describe. So we recommend, if you're installing PC-BSD, keep the default data sets, but then if you want, go in and add as many more as you want, whatever's useful for you. Yes?
Is there a maximum number of data sets or a number it shouldn't exceed?
No. Post-install, I can go back into Disk Manager, and again, I can select the name of my pool, and I can go in and create a data set. And again, it will let me set a bunch of properties on that as I'm creating the data set. The other way that you can set up your storage is to create things known as ZVols. And think of ZVols as basically a raw disk. So I can set aside, say, 40 gigs of my storage and use that. Basically, I can format it with any file system I want. And even though I've gone and formatted it with a different file system, all of the benefits of ZFS are still happening at the disk block level. So often this is used for people who use iSCSI, because basically on the network it just appears as a raw disk, which an iSCSI client can format and use for storage. And you could also just create, say if you needed a FAT32 file system on your PC-BSD desktop, you could create a ZVol and use that. So basically it's a raw block device. In reality, it's just so much space managed by ZFS. To create a ZVol on FreeNAS, again, I already have a volume. I click on Create ZVol, surprisingly enough. Give it a name, set the size, and click Add ZVol. Now we start getting into some of the cool stuff that happens because we're a copy-on-write file system. So a lot of file systems provide the ability to take a snapshot, basically what the file system looks like at this point in time. And a lot of file systems, that's a very expensive operation. It either makes a really huge file, or else you have a limitation on how many snapshots you can create and manage. With ZFS, as long as you have the disk space, there's no limits of how many snapshots you can take. When we say low cost, we mean instantaneous. You click Create Snapshot, bam, the snapshot is there. The other part that makes it low cost is when you create a snapshot, it's 0 bytes in size. Basically, it is a point in time to ZFS, and as those files referenced by the snapshot change, that's when your snapshot starts to grow. So the creation itself is very low cost. And it really offers a very slick way of having access to former versions of files. So you no longer have to take backups, store them off-site, call the administrator, I need the file from last Tuesday, to do stuff like that. On the system itself, you'll have local copies of snapshots where you can go and access the data that you need. And for this reason, we recommend, especially if you're making lots of edits to files, take snapshots every 5 minutes and go back to whatever 5-minute increment in time to grab the file that you need. And I'm going to show a couple of examples of this. So on a FreeNAS system, because this is a storage box, typically you're creating local snapshots, and often you're replicating them to another system in case they're needed by clients. So we can go in and create, basically you're creating the schedule of how often the snapshots will occur. And The system itself will do it for you automatically. So you just turn them on, you select the volume or the data set you want to snapshot, and you specify when you'd like that to occur. PC-BSD, there's a couple of tools that have snapshot schedulers built into them. The first tool is called Warden. So FreeBSD has a mechanism known as jails, which provides a lightweight form of virtualization. And Warden is the GUI utility for managing your jails. So on this system, I happen to have created 3 jails, and I have a FreeBSD jail highlighted. Right now, snapshots are on, but I could turn it on, and I could schedule when they occur and how often to keep those snapshots. One of the things you might notice is one of my jails is called Debian, because Debian is actually installed in a jail with ZFS underneath it, managing that portion of the file system.
Is that Debian with a FreeBSD kernel?
Yes.
Okay.
So it's actually using Linux emulation. So parts of it is funky and parts of it work and parts of it don't. So I wouldn't use it as my production Debian server, but if I needed to run a particular Debian application on a system, that's one way of doing it. The other utility, which we're going to spend a little more time on, that comes with PC-BSD is the backup utility. It's called Life Preserver, and it's meant to be that, so that you can always have copies of your files or just rescue your system if the ship really starts sinking. So in Life Preserver, I can go in and create my snapshot schedule. So I say how often to do them, how many snapshots to keep, either a number or for a certain number of days. Snapshots are cool to actually have the system automatically keeping track of file versions. The cool part is to actually be able to access those versions of files if you need to. So one of the things that Life Preserver does is it gives you a nice graphical way to scroll through periods of time and say, gee, I wish I had not deleted that file that I created last Tuesday. So let's go back to last Tuesday at that point in time, and let's click that version of the file. And now I'm running that version of the file. The other thing it can do is it can replicate your snapshots to another system. It integrates very nicely into FreeNAS if you already have a FreeNAS box. But you can send it to any system running ZFS, and it does it over SSH. And if you do send remote snapshots, the benefit is you can either clone systems from that snapshot, or you can restore a forked installation from a known good point in time. So let's see what that screen looks like. So it's hard to show in a screenshot. We do have more screenshots in our documentation, but I encourage people to try it. So on this system, it's creating snapshots automatically, and it's almost like being in Time Machine. I can go and scroll through various points in time, either using the slide bar or by scrolling one at a time. Once I select my point in time, I can say what part of the file system I want to look at. I happen to be in my home directory. I can go browsing through my directories. And if I find anything that I want to restore, I just right-click and restore. The nice thing about how it restores is it doesn't replace the current version, so it actually gives it an extension. And I could go in and restore 20 versions of the same file.
Yeah. Is this replicating like lock devices? Really just a difference?
Yeah, so it's replicating snapshots themselves. It's almost similar to rsync because the snapshots themselves are only going to be the difference from the last snapshot.
Right, but is it the file or is it just the block?
The blocks.
It's the new blocks, and it's better than rsync because it knows where they are as opposed to having to look for them.
Correct. Another feature that we have built into ZFS, one of the design goals was to create a file system that was self-healing, that would actually try to let you know when data was being written corruptly and to try to fix that. So copy on write helps with that. The other way it does it is it checksums every block as it's writing it. When you do a scrub, what you're telling ZFS to do is to go through all of the disk blocks, check all of the checksums, and make sure that they all match. And if ZFS finds checksums that don't match, it'll actually record that. And then it will go out and see, can I find identical data that was written elsewhere? And if it does, it will fix the disk block and it will fix the checksum. So scrubs are a very good thing to do. And what we recommend is that if you're using consumer disks, you do a scrub about once a week. And if you're using very good disks, you can probably do once a month. There's no sense doing scrubs if you're not going to read your scrub report afterwards. Because what you really want is an idea, is ZFS fixing a lot of disk blocks? If so, there's a problem with one of my disks, and I should take a look at that.
This could also force a failure on your RAID, which you otherwise, wouldn't necessarily see until
Yeah,
it was underload.
which can be a good thing or a bad thing.
Can force what?
Just failure. In the back.
Sorry, I don't mean to go back, but on the snapshots,
Yes.
do you have to be root to see the snapshots? If okay.
So root actually makes them, but when I was in that screen looking at my disks, I was through with the root home directory
Great.
and restoring my own files.
Perfect.
Now, obviously, if I went into Etsy, I would have to have proper permissions in order to start restoring files here. Others question of that?
Yeah, if the scrub does find an error that it can't fix, can you alert on that to out the
FreeNAS
external
will.
system?
FreeNAS will, so we actually have an alert mechanism, and as alerts are made, emails sent to the root user that you specify. Yeah.
And does it have like you talked about the alerts, does it have like an SNMP thing where you can ask, do you have any errors of this type in the last year?
Right.
Now, that's an interesting question. So SNMP is built into ZFS, and I know we're using the FreeBSD version called BSNMP,
Right.
but I'm not sure what the ZFS OIDs are.
Okay, I was just curious, because then you can make like a thing on your little, I guess, dashboard or whatever you're running.
Yeah.
And it will go turn red.
No, so that would be interesting. If you go to our documentation on the section on BSNMP, it says where the OIDs are listed. It'd be interesting to see if there's any ZFS ones. And if there isn't, I don't know, does anybody have ZFS OIDs?
That's more what I was wondering, is it because we use Spectrum CA, and I was wondering if there's a way to alert into that, or if we have to come up with our own way to get it in there.
Well, worst case is you could have it send something like, if you had RT or something, open a ticket.
Yeah.
There's a question in the front, yeah?
Yeah, have you gathered any major differences on scrubbing between a data set that has a lot of small files versus one that has fewer really big files?
Shouldn't make a difference because it's at the block level. In FreeNAS, whenever you create a volume, it automatically schedules a scrub for you. The default is every Sunday at midnight. And you can go in and edit that. That's not a convenient time. You really want your scrubs to happen when there's not a lot of disk activity because it is I/O intensive. In FreeNAS, we do have a volume status area, and it will show you the status of your last scrub. And on any ZFS system, you can always type zpool status to take a look at the status of your zpool. And in PC-BSD, you can start a scrub either from Disk Manager or Life Preserver. We have a couple of screenshots for both. So on FreeNAS, we have something called ZFS Scrubs. This one I've created a volume 1, and it already has, it's hard to see, but there's already the schedule here. I could go in and edit that if I wanted a different schedule. PC-BSD, if I'm in the Life Preserver, I can go up to Disk and just start a scrub. It will always show you in the Life Preserver utility itself the status of your last scrub, and it will be either green or red. So if there is any errors, that will be highlighted in red. One property everybody was waiting for until it came and they found out it sometimes killed their systems was deduplication. So deduplication is interesting because it tells ZFS not to write duplicate data. So if you're doing things like spinning up a lot of VMs, you obviously have a lot of duplicate data. This can improve the efficiency of your storage because you're not going to be writing all of these duplicate data blocks, but it does come at the price of performance. So it can really slow down the system unless you have streaming hardware. What we often recommend to people is you probably don't want deduplication, you probably want compression instead. With the newer compressions built into ZFS, you have a almost instantaneous speed for very good compression. So typically, traditionally the problem with compression was it was either really slow or it was really crappy compression. So we get really good stuff really fast. So the compression algorithm they recommend now is LZ4, which is basically instantaneous. The problem with deduplication is deduplication uses tables to keep track of its disk blocks, so it's not writing duplicate data. All of those have to fit into your ARC and LV ARC, and it will roll the system over if the dedupe tables get too big to fit in there. And that's typically the problem that people have. So the general rule of thumb is 5 gigs of RAM L2 ARC for every terabyte of storage. Whereas compression, you don't need that much RAM. The last cool thing I want to leave you with is something that in the latest version of PC-BSD, it's something that Solaris used to do. People who are used to ZFS on Solaris. Something called boot environments. So boot environment is basically a snapshot of the operating system. So because it's a snapshot, it's instantaneous to take it. It doesn't cost you anything to take it. And this can be really handy. So if you're going to do a risky operation like upgrade a production server, maybe start mucking about with some config files on your server, we have developers who do it to create their development environments. They don't want to mess up their own system. If you're going to do something like that, go in and create a boot environment. In PC-BSD, it will be automatically added to your Grub2 boot manager. And if everything blows up, reboot the system and go back to your previous point in time. It's as easy as that. Creating a boot environment takes all of half a second. The longest thing is to open up the screen called the boot up configuration. You will always have your default boot environment. I click the plus, I give it a name, and that's what's going to show up in my grub menu. Then I can go in and muck with the system all I want. Here's an example. I created a boot environment called before upgrade, and if the upgrade goes south, all I have to do is change to this boot. We have all kinds of documentation, so both PC-BSD and FreeNAS have very comprehensive user guides that are available on their websites. The ZFS Best Practices Guide really is. There's a lot of really good information on using ZFS. And for those of you who rather watch somebody than read something, Becoming a ZFS Ninja is a very good video. And for those of you madly writing all of this stuff down, if you don't already have the URL for the slides, there it is. And here's my contact info.